Success factors in test automation. In this video, we will discuss the success factors that apply to ongoing test automation projects. The focus will be on influences that impact the project's long-term success. So, we will not consider factors influencing the success of a test automation project in the beginning, pilot stage. There are many major success factors for test automation, such as Test Automation Architecture, TAA. The Test Automation Architecture, also referred to as TAA, is a set of technologies, tools, and processes and people that make up your test automation solution. It should be closely aligned with the architecture of your software product and designed to meet the specific needs of your project. For example, you would not use the same test automation architecture, TAA, for web application as you would do for a mobile app. The test automation architecture, TAA, should include functional and non-functional requirements that are most important to support. Creating a clear architecture will ensure smooth sailing for you and your team down the road. The test automation architecture, TAA, is the most effective when it prioritizes understandability, performance, and learnability in the code. This makes the code base easier to work with for everyone involved. It's beneficial to involve software engineers familiar with the architecture of the software under test. By including software engineers, they can provide insights into how the code should be organized or what coding standards to follow. System under test testability. To automate our tests, we need to design the system under test, SUT, for testability. For GUI testing, this would ideally mean that data and interaction for the graphical interface are decoupled from its appearance. Decoupled means that the system under test, SUT, should be constructed so that the tests can be written independently of the GUI. So, as long as the behavior of the system under test, SUT, stays the same, we can modify the implementation details of the system under test, SUT, without affecting our tests. Any software is made up of multiple segments of code called methods, functions, or procedures. Those segments call each other to accomplish a specific functionality required by the software. Each of those segments has its own unique header or signature that is used when the segment needs to be called. In application programming interface or API testing, we verify the API's functionality, reliability, performance, and security. This often requires making classes, modules, or the command line interface publicly accessible for testing purposes. For instance, if the SUT is back-end system for an online store, we might automate a test to send an API request to a public interface for a list of products and check that the expected results are returned. Additionally, the system's functionality must be extensively documented so that the testers are aware of what to anticipate from each communication with the system under test, SUT. It's best to start with the testable parts of the system under test when beginning to automate testing. Often a successful automation project hinges on how easy it is to write automated scripts. The goal of the test automation engineer, also known as the TAE, is to identify modules or components of the system under test, SUT, that are easily tested with automation and start from there to provide a successful proof of concept. The proof of concept is then used to build confidence in the organization for further automation efforts. Test automation strategy. Having a solid and reliable test automation strategy is key to maintaining the stability of your software application under test. A test automation strategy covers what, where, when, why, and how you will automate your tests. When creating your strategy, we should consider the costs, benefits, and risks of using it on different parts of the codebase. Notice that we should create automated test cases for both the user interface and API to compare results and ensure consistency. So, for example, when a field such as phone number is required when submitting data in the user interface, the same field should also be required when making a request via the API. In addition, it's worth noting that the test automation strategy might not be effective for both the old and new code in the system under test, SUT. So, in such a scenario, it might be necessary to make the decision to only automate the regression tests for the new code and not the old code. Test Automation Framework, TAF. A test automation framework, also referred to as TAF, is a tool that provides an environment for test automation. It typically contains a test harness and associated test libraries. A test harness is a collection of stubs and drivers needed to execute a test suite. We talked about stubs and drivers at the foundation level, but as a quick reminder, a stub is a fake piece of code that stimulates the behavior of the real code it replaces in a test. A driver is a component that replaces another component and controls or calls a test item in isolation. An easy-to-use, well-documented, and maintainable test automation framework, TAF, encourages a consistent approach to automating tests. To establish a test automation framework, TAF, that's easy to use and maintain, certain actions must be done. Implement reporting facilities. The test reports should state the quality of the system under test, SUT, for example, data related to pass or fail, error, not run, and aborted status. Reporting should provide information to testers, test managers, developers, and project managers about the quality so that they can have an overview of it. Enable easy troubleshooting. The Test Automation Framework, TAF, provides not only a tool for test execution and logging, but also an easy troubleshooting method for tests that fail. The reasons a test might fail include failures found in the software under test, failures found in the test automation solution, problems with the tests themselves or the test environment. Address the test environment appropriately. Consistency in the test environment is essential for automated testing to be effective. Therefore, having a dedicated test environment is crucial. Without regulating the test environment and data, tests will not be accurate, wasting time and yielding false results. Document the automated test cases. The test automation goals need to be clear, such as which sections of the app are being tested, how much testing is necessary, and what attributes are being tested. Like functional versus non-functional attributes, this must be set down in writing so there is no confusion later on down the line. Trace the automated test. The test automation framework should allow the test automation engineer to follow each step back to its respective test case. Enable easy maintenance. The automated test cases should be easy to maintain so that maintaining them won't take up a lot of time. The amount of work required to keep the system under test, SUT, up to date must be balanced with the size of changes made. To achieve this, test cases must be easily understandable, changeable, and accommodate new additions. In addition, as much of the automated testing software as possible should be reused to minimize modifications. Keep the automated tests up to date. When requirements change and tests start failing, don't disable the tests. Fix them. Plan for deployment. To avoid complications, ensure your test scripts can quickly and without issue be deployed, swapped out, or redeployed as necessary. Retire tests as needed. If a test script is no longer useful, dispose of it. Monitor and restore the system under test, SUT. If you want to run a test continuously, the system under test, SUT, must be monitored constantly. If the system under test, SUT, faces a fatal error like crashing, the Test Automation Framework, TAF, should be able to recover, skip the current case, and resume testing from where it left off with the next case. Maintaining test automation code can be just as complex as the code for the system under test, SUT. This is because of different test tools, verification methods, and testware artifacts, such as input data, oracles, and reports. It's essential that the test code is maintainable to avoid issues further down the line. With these maintenance considerations in mind, in addition to the important items that should be done, there are a few others that you shouldn't do. Don't create code sensitive to the interface. For example, code that would be affected by changes in the graphical interface or non-essential parts of the API. Don't create test automation that is sensitive to data changes or has a high dependency on particular data values, such as test input depending on the other test outputs. Don't create an automation environment that is sensitive to the context, such as the operating system date and time, the operating system localization parameters, or the contents of another app. In this case, controlling the environment is key, so use test stubs as necessary. The more success factors that are met, the greater chance the test automation project will have for success. All factors don't have to be required, though, and it's rare for all of them to be met. Before beginning the test automation project, it's essential to evaluate the potential success of your test automation project by considering various risk factors. This will give you a better understanding of what measures need to be put in place and which items are missing or still need work once the test automation architecture is implemented. To review, we looked at some key things to consider when maintaining test automation code. These include making sure that the code is easy to understand and change, as well as being able to quickly and without issue be deployed. We also looked at some of the things that you shouldn't do when creating code for a test automation project, such as creating a code sensitive to the interface or data changes. Finally, we looked at some technical success factors for a test automation project. In the next section, we will look at preparing for test automation.